Using electrode potentials to predict chemical reactions. In an electrochemical cell, chemical energy is converted into electrical energy. We can predict what reactions will occur by looking at the electrode potential values of the two half cells. So here we've got the zinc-silver half cell. We can see that we've got zinc on the left-hand side, which means that if this is our left-hand side, this will end up being our oxidation, which means that we've got silver on our right-hand side, which means it will be our reduction. It also means that this will be our positive electrode and drawn on the right, and this will be our negative electrode and drawn on the left. So let's label our parts of our cell. So on the right-hand side, we've got silver. Silver's a solid metal. Here we need a solution that contains 1 mole per decimeter cubed Ag+. So something like AgNO3. Here on the left-hand side, we've got zinc as our electrode because we're doing a zinc half cell. And we've got a solution that contains 1 mole per decimeter cubed Zn2+, so something like Zn nitrate twice. We've got a salt bridge. Remember, our salt bridge is usually saturated with KNO3AQ. I'm just going to put a little star here, put a little note at the top. Couldn't use KCl here. This is one of the examples where we couldn't use KCl because silver ions in the silver half cell would react with the chloride ions. Cl- ions would react with Ag+ ions, and that would change the concentration of the silver ions and affect the EMF. It would precipitate out as well. So the half equation with the more positive, that's our right-hand side, goes forwards, reduction. So we copy what was written, which is Ag plus Aq plus E minus goes to Ag solid. The more negative, the left-hand side, goes backwards, oxidation. So instead of being Zn2 plus to Zn, it's going to be Zn becomes Zn2 plus. It's oxidized to zinc ions and 2 electrons. In order to combine those, we need to make sure the number of electrons lost is equal to the number gained. So I'm going to times the top half equation by 2 before I combine them. So 2Ag plus Aq combined with zinc solid gives me zinc 2 plus ions. This way there's 2 electrons transferred and 2 silver solid. The standard electrode potential is still right-hand side minus left-hand side, which is 0.79 minus 0.76, which is 1.55 volts. So what else might they ask you? Well, if you actually were to remove the high resistance voltmeter and replace it by a bulb or an ammeter or just a wire, then current will flow through the circuit. And when that happens, the reactions will occur and the zinc electrode will start to decrease in mass. And that is because if you look at the equation, zinc is being oxidized to Zn2+. So it's disappearing. So Zn is oxidized to Zn2 plus Aq. Ag plus Aq is reduced to Ag solid, so silver electrode mass increases. If the mass of the zinc electrode decreases by 0.65 grams, what will happen to the silver electrode? So if we just rewrite the equation, we had Zn plus 2Ag plus becomes Zn2 plus 2Ag. And we've been given the zinc electrode's mass. So we can find the number of moles of zinc by doing mass over Mr. So mass 0.65 divided by the Mr of zinc, 65.4. Get that on our calculator, 9.94 times 10 to the minus 3 moles. Now, according to the equation, the ratio between zinc and silver is 1 to 2. There's 2 silvers for every zinc. So the number of moles of silver is 2 times the number of moles of zinc. And then we can do the mass of silver by timesing by the Mr, 107.9. And that gives us a mass of 2.14 grams. I have another example of a question like that, but that's just a tiny bit harder. So this time it says a half cell is made by a strip of iron metal, so that's Fe solid, and a solution of iron 3 sulfate, so that's Fe3+. The second one is X solid and a solution of XSO4. So we haven't got the Roman numerals to tell us the charge, but we know that a sulfate ion is 2-, so we know that X must be 2+. It says the iron electrode loses mass. That tells us it is oxidized because it's becoming the iron. So we know that Fe is going to Fe3+, it's losing mass, which means that X2+ must be gaining electrons and becoming more X, gaining. So we could combine these two together by making the electrons match and come up with an overall equation for this reaction. So 2Fe plus 3X2 plus equals to 2Fe3 plus 3X. And then we can do the same sort of calculation. So we've got a mass of iron, so we can do number of moles of iron. So we would look up the Mr of iron in the periodic table, work out the moles, use the ratio. So for every Fe to X, we've got 2 in front of the Fe and 3 in front of the X. So the number of moles of X would be 3 over 2 times. If we do that on our calculator, and then we can do mass of X. No, we can't do mass because that's not, the question is to, we've got the mass, the question is to find the Mr. So Mr is mass over moles. So 1.79 divided by 0.0282. I'm going to get an Mr of 63.4, and if we use our periodic table, X equals copper.